this is my 8th video on vector calculus. Today I am going to start vector integration. Here we see the definition of vector line integral. The line integral of a vector A along the curve C is defined to be the sum of the scalar product of A and dr and is represented by integral of C A dot dr. And note the important formulas. If C is a closed curve which do not intersect anywhere, the line integral is integral of closed curve C A dot dr. The work done by the force is integral of C F dot dr, where F is force. It also represents the velocity of the fluid. We find F is said to be irrotational. We take integral of closed curve C F dot dr is equal to 0. The position vector r is equal to xi plus yj plus zk. Dr is equal to dxi plus dyj plus dzk. Take problem. If f is equal to xyi plus yzj plus zx into k, evaluate integral of C F dot dr, where C is the curve represented by x is equal to t, y is equal to t square, z is equal to t cube. T varies from -1 to +1. Here we find integral of f dot dr, right? But x, y, z in terms of t, and the interval is also varies t only, right? That's why we simplify f is in terms of x, y, z. So we have to simplify in all the terms in terms of t. Note that f value and then substitute x, y, z value. Here x into y, here t into t square is t cube I, y into z, t power 5 into j, z into x, t cube into t is t power 4 into k. And find dr is equal to dxi plus dyj plus dz into k. So we find the derivative dx, dy, dz. Here x value, x is equal to t, y is equal to t square, z is equal to t cube. Differentiate with respect to t, x is dx, t is dt. Y is dy, t square differentiation is 2t into dt. Here z is equal to t cube, differentiate with respect to t, dz is equal to t cube is 3t square into dt. Substitute dx, dy and dz. So we get f1 dr in terms of t. First we find f dot dr, substitute and then take dot product. Already note that the dot product I dot I is 1, j dot j is 1, k dot k is 1. Other dot products are 0. Take I dot I is 1, t cube into dt. J dot j is 1, t power 5 into t. It is 2t power 6 dt. T power 4 into 3t square. Here 3t power 6 into dt. In all the terms, dt is common. Take outside. Here only cubic term. Write as it is t cube. Here t power 6. Here also t power 6. Add these two. 3 plus 2 is 5t power 6. In this problem, we find integral of f dot dr. Here integral t varies from -1 to +1. Here -1 to 1. Substitute f dot dr value. Integrating with respect to t, t cube integration is t power 4 by 4 plus 5 into t power 6 integration is t power 7 divided by 7 between the limits -1 to +1. Apply upper limit minus of lower limit first term and then take second term. 1 by 4 into upper limit 1 power 4 is 1 minus of lower limit t is -1 whole power 4 is +1, right? Plus 5 by 7 into upper limit 1 power 7 is 1 minus of lower limit t is -1 whole power 7. So power even idra we get +1. Here power is odd, that's why we get -1. Simplify, we get 10 by 7. Take second problem. Evaluate integral of C f dot dr where f is equal to xyi plus x square plus y square into j along first one, the path of the straight line from 0, 0 to 1, 0 and then to 1, 1. Second one, the straight line joining the origin and 1, 2. Here, in these two conditions, we find integral of c f dot dr. F is given. First, we find first condition. Here, the path of the straight line from 0, 0 to 1, 0 and then to 1, 1. So, first we take the diagram in x-axis, y-axis. Here point 0, 0 to 1, 0. 0, 0 is nothing but origin. Here 0, 0. 1, 0. Here x value 1, y value is 0. In x-axis, y value is 0. So take x is equal to 1. This point, here this line represent x is equal to 1. So note that the point x is 1. In x-axis, y value is 0. And then this path to another point 1, 1. So 1, 0 to 1, 1. Here x is 1, y is 1. So take the point x value 1, y value 1. We get two paths, right? Here origin to 1, 0. Take note that the point O, here A, here B. So the straight line OA one path and AB another path. That means we find the integral f dot dr is equal to integral of OA path plus integral of AB, called as equation 1. In both the term we find f dot dr, right? So separately we find f dot dr, substitute f value and dr value, take dot product. I dot I is 1, so xy into dx, j dot j is 1, x square plus y square into dy. So k is not given, 0 into k is 0 into k becomes 0. So find first integral of OA f dot dr. So along OA, this means this line O to A. This line represents y is equal to 0. Here y is equal to 0. Find the derivative, dy is equal to 0. Take the substitution in terms of y. That means y in terms of x. That's why we take the limit is x varies from this point to this point. Here this point x comma y, here x comma y. X varies from 0 to 1, right? So integral of OA f dot dr. Substitute f dot dr value. Here y is 0, this value becomes 0. Dy is 0, 0 into this value becomes 0. We get integral of OA is 0. Along AB, this line representation, x is equal to 1. Find the derivative x with respect to x. Here x is dx. 1 is a constant, differentiation of constant is 0. We take the substitution x value, that means we get x in terms of y. That's why we take the limit is y varies 0 to 1. Here this point y value is 0. Here this point y value is 1. So here 0 to 1. Integral of AB f dot dr is equal to integral of 0 to 1. Substitute x is 1, dx is 0. Here dx is 0, 0 into xy is 0 plus x is 1 square, it is 1 plus y square into dy. 1 with respect to y, y square integration y cube by 3 between the limits 0 to 1. Apply our upper limit, y is 1, here 1 by 3, lower limit becomes 0. 1 plus 1 by 3 is 4 by 3. Substitute integral of OA and integral of AB in equation 1. Equation 1 becomes integral of C f dot dr along OA 0, along AB 4 by 3. We get 4 by 3. Next, second condition. We find straight line joining a point 0, 0 to 1, 2. Here 2 points are given. That's why we are using the straight line formula. y minus y1 divided by x minus x1 is equal to y2 minus y1 divided by x2 minus x1. Here first point take x1 y1, second point x2 y2. Substitute this y1 0, x1 0, x2 is here y1 y2 minus y1, here y2 is 2 minus 0, x2 minus x1, here 1 minus 0. Simplify y by x is equal to 2 by 1. Cross multiply 1 into y, x into 2, x into 2 is 2x. We get one equation y in terms of x. So find the derivative dy is equal to 2 into dx. So here y in terms of x, that's why we have to write the limit is x in x varies from, here this point, x varies from 0 to 1. Yeah, integral of c f dot dr is equal to integral of 0 to 1 x into 2x into dx. That means here f dot dr value is xy into dx. Here y value 2x plus x square plus y square. Here y value is 2x. Here 2x whole square is 4x square. Here dy is 2 into dx. Simplify. We get 2x square plus 2x square plus 8x square. All the terms power 2. That's why adding these three values, 12x square with respect to x. 12 into x square integration is x cube divided by 3. Apply upper limit minus of lower limit. Here 3 4s are 4 into 1 4 minus 0 becomes 4 minus 0, we get 4. Take next problem. If f is equal to 3x square plus 6y into I minus 14yzj plus 20xz square into k, evaluate integral of f dot dr from 0 0 0 to 1 1 1 along x is equal to t, y is equal to t square, z is equal to t cube. Here we find integral f dot dr xyz in terms of t. That's why simplify f in terms of t. Write f value dot dr value. First we take dot product I dot I1, j dot j1, k dot k1. That coefficient we take product. Substitute x value. X is 3d square plus 6d square. Dx already find in first problem, same given data x, y, z, right? Here dx is t differentiation is dt, dy is 2t into dt, dz is 3t square into dt. Take product and then simplify. We get 90 square dt minus 28 t power 6 dt plus 60 into t power 9 into dt. Here we find integral of c f dot dr integral. Here xyz in terms of t, that's why we have to find the limit in terms of t. Here the point xyz, here also xyz. Take this point, we find t limit. Take x is 0, t value 0. Take x is 1, t value is 1. Same thing we take these two, we get same limit. So t varies from 0 to 1. Substitute f dot dr value. Here 9 into t square integration is t cube by 3 minus 28 into t power 6 is t power 7 by 7 plus 60 into t power 9 is t power 10 divided by 10, between the limits 0 to 1. Apply upper limit minus of lower limit, we get 5.